Hello, so today we're going to be talking about factoring trinomials, and we're going to be talking about specifically where the leading coefficient, so the number in front of the x squared equals 1. Okay, so we're going to be looking at trinomials where it's 1x squared plus a number times x plus another number. Okay, so a, b, and c are just numbers. And just to point out, the reason why they're called trinomials, tri means 3, so there's 3 terms. Okay, so here's an example at the top of the page. X squared plus 3x minus 10. So see how it says A, B, C? So the A would be 1, the B would be 3, and the C would be negative 10. Okay, so step 1, you're going to just set up 2 sets of parentheses. All right, step 2, it says to look at the first term of your trinomial. Okay, so we have a 1x squared. You're going to take the square root of the first term and place it in the first spot within each set of parentheses. Okay, so the square root of x squared would be x, right? X times x gives you x squared. So we're going to put an x here and here. Okay, now the third step may take a little bit of trial and error, but you have to find 2 numbers that add to b. So remember we said b was 3. And multiply to c. Okay, so c is negative 10. So you have to come up with, I usually write this on top, A-M, right? Add, multiply. That's why some people call it like the AM method. We need to come up with 2 numbers that add to 3 and multiply to negative 10. All right, so if you look down here, I'm just going to slide this up. If you look down here, I found those 2 numbers, okay? 5 and negative 2. 5 plus negative 2, when you add them, it gives you b. It gives you the middle term, which is 3. And 5 times negative 2, when you multiply, it gives them c. Okay, it gives you negative 10. So what we're going to do is we're going to take those 2 numbers, the 5 and the negative 2, and we're going to put them in the second spot within each parenthesis. Okay, so positive 5 and negative 2. Now, if you look down at the bottom of the page here, or not really the bottom, I should say halfway through, what you'll notice is, although this is a trinomial, right, sometimes you have to factor out the greatest common factor first. And you want to do that whenever you can. If you see a greatest common factor that could come out of each term, right, you want to do that first before you start. So if you look at each of these terms, aren't they all divisible by 3? So we first pull out a 3. Now notice, when you pull out a greatest common factor, we do not set up 2 sets of parentheses like we did here. When you pull out a greatest common factor, you always set up 1 parenthesis, right? And you're going to put in that parenthesis what you're left with after you took out the greatest common factor. So when we take a 3 out of each of these terms, okay, I'm left with x to the 4th, then bring down the minus. 18 divided by 3 is 6, okay, and I'm going to bring down the x squared, and then bring down the plus sign. 15 divided by 3 is 5. So all I did was just divide each of these terms by 3, and that's what we put inside the parentheses. Okay, now once the greatest common factor is factored out, you just bring that down. That's going to just keep coming down in every step. And now you're going to factor the trinomial that you're left with in the parentheses. So remember, we set up 2 sets of parentheses. We take the square root of the first term, right? So you want to say to yourself, what times itself gives you x to the 4th? X squared does, so that's what goes here and here. And then we want to come up with 2 numbers, I'm going to, again, write this on the top here, that add to negative 6 and that multiply to positive 5, okay? So, first of all, if they're going to multiply to a positive, they have to have the same sign, right? So they're both going to be positive or they're both going to be negative. But if they add to a negative, well, then there you go, they both have to be negative. So negative 5 plus negative 1 gives you negative 6, and negative 5 times negative 1 gives you positive 5. So negative 5 and negative 1 you're going to put in the second spot in each parenthesis. Okay, and this right here is factored completely. Okay, so I'm going to take a look at not all of the odd examples, but some of the odd examples with you on this page as well as the next page. All right, so let's start with number 21. Okay, so we're looking at the column on the right over here. So here, you want to look, and we have a trinomial, right? 3 terms, 1, 2, 3. Now, there's no greatest common factor to factor out because this is just a 1x squared. So what we're going to do is we're going to set up our 2 sets of parentheses. We're going to take the square root of this first term, and we're going to put it in the first spot in each parentheses. So the square root of x squared is x, because x times x gives you x squared. And then we're going to come up with two numbers that add to negative 19 and multiply to positive 48. Now, we know that if they multiply to a positive, they have the same sign. So it's either going to be plus, plus, or minus, minus. But if they add to a negative, well, then they both have to be negative. So I'm going to put my negatives in here. Okay, now it's up to you. There's a couple ways you can do this. What you could do is you could list out all the factors of 48, right? So if you want to make a list over on the side here, 48. Okay, so we know they're going to be negative. So 48 divided by negative 1 is negative 48. 48 divided by negative 2 is negative 24. 48 divided by negative 3, okay, I'm just putting multiplication symbols here, is negative 16. 48, well, there's a lot that divides evenly into 48, right? 48 divided by negative 4 is negative 12. 48 does not divide evenly by negative 5. 48 divided by negative 6 would be negative 8. 48 does not divide evenly by negative 7. And then once I try 48 divided by negative 8, well, it's already on my list, so I know I've come up with all of the factors, all the pairs of numbers that multiply to 48. So now you want to look down the list and say, well, which of those add to negative 19? So the first two don't, the second two don't. Look at this right here, negative 3 and negative 16. Okay, this is the pair of numbers I'm going to use. So I'm going to put those within my parentheses. So we have a negative 3 and a negative 16. And you could put those in either order. Okay, you could put if you wanted to put the negative 16 first and then the negative 3, it does not matter. Okay, and then you always want to look and say, well, can I factor anything further? Nope, we cannot. So I'm going to close up my parentheses. I'm going to box off my answer. Okay, I want to show you a quick trick too. Instead of listing out all the factors by hand, if you want, in your calculator, you can click y equals, okay, and you could type in this number here that we're multiplying to divided by x. So if you type in 48 and then divided by x, oop, I hit it. Is that right? No, I hit time, sorry. So divided by, you can go to your table of values. So if you hit second graph, and it'll list all the pairs of numbers that multiply to 48. So see how we have 1 and 48, just like we have here. Actually, these are all negatives. I mean, if you want, you could scroll up to the negatives, like that. But it'll list out all the pairs of numbers that multiply to 48. And then you don't have to sit there and go 48 divided by 1, 48 divided by 2. So if that's easier for you, again, just go to y equals and type in the number we're trying to multiply to, divided by x, and then just go to your table of values. Okay, so let's take a look at number 23. So with number 23, let's see. I first want to say, can I factor out a greatest common factor? And I cannot. So I'm just going to open up my two sets of parentheses. Okay, in the first spot, we're going to put the square root of the first term. So the square root of x to the fourth would be x squared, right? Because x squared times x squared gives you x to the fourth. Okay, now we have to come up with two numbers that add to our b term, to our b number, and multiply to our c number. Okay, so if you want to make a list off to the side again, you can. That's up to you. I'm going to first put my signs in again. And, this is the same as the one above. If it multiplies to a positive, we know they're going to have the same signs, right? But since it adds to a negative, don't they both have to be negative? And with the trinomial, the only time you're going to have one of each sign is if you're coming up with one like this, or this, where it multiplies to a negative. Remember, if it multiplies to a negative, they have different signs. If it multiplies to a positive, they have the same signs. Okay, so you can make a list off to the side if you want, but two numbers that multiply to 24 and add to negative 10 would be negative 6 and negative 4. Okay, you can put them in either order. It does not matter. But what you'll notice with this one is, look at this right here. This one can factor further. This is a difference, and both of these are perfect squares. Okay, this one's not, because the 6 is not a perfect square, but the square root of x squared is x, and the square root of 4 is 2. So what we can do is we can factor, we could set up two sets of parentheses underneath this, and factor it further using dots. So remember, with dots, you have one addition sign and one subtraction sign. You take the square root of this first term and put it in the first spot in each parenthesis. And then you take the square root of the second term and put it in the second spot in each parenthesis. Now, when you do this, don't forget to bring down this x squared minus 6, because remember, that's one of your factors as well. All right, so this time we have 3 factors. Okay, x squared minus 6, x plus 2, and x minus 2. And unfortunately, if you leave it like this, it is not fully factored, so make sure you always factor completely. Okay, if you turn to the next page, we're going to take a look at some of the odd examples on this page, but not all of them. All right, but let's start with number 25. Now, if you notice, when you look at this, look at all your terms. We can actually factor out a greatest common factor. Now, you have to decide, do you want to factor out, you can write 2 divides evenly into all of them. Do you want to factor out a positive 2 or a negative 2? Well, it all depends on this first term. We call this the leading coefficient, right? Coefficients are the numbers in front of the variables. So here, this is the one in front. This is the leading coefficient. If this is negative, you want to factor out a negative. Whereas if it was a positive, you would want to factor out a positive. So here we're going to factor out a negative 2. Okay, so take a minute and actually write this in your notes, because this is really important, okay? You're going to see this a lot. Okay, so basically what we're doing is we're factoring out a negative 2. So when we do, we're just dividing each term by negative 2. Now remember, when you factor out the greatest common factor, you only open up one set of parentheses, not 2 of them, okay? So negative 2 divided by negative 2 is positive 1, so it leaves us with positive 1x squared, or just x squared. Positive 18 divided by negative 2 is negative 9, so this will leave us with negative 9x. And then positive 72 divided by negative 2 is negative 36. I mean, basically what happens when you factor out a negative is your signs change, right? It went from negative, positive, positive to a positive, negative, negative within the parentheses. Okay, so let's factor further. Now remember, this greatest common factor just keeps coming down. Don't forget about that. And since we have a trinomial where the leading coefficient is a 1, we're going to open up 2 sets of parentheses. I'm going to put the square root of the first term in the first spot. And then I want to come up with 2 numbers that add to negative 9 and multiply to negative 36. Now this time they're multiplying to a negative. So it means we're going to have one of each sign, right? The only way to get a negative when you're multiplying is if one is positive and one is negative. Okay, so in order to come up with the numbers that multiply to negative 36 and add to negative 9, you could, it may take a little bit of trial and error, or you can make the list on the side of your paper, negative 36 divided by 1, negative 36 divided by 2. Or you can do it in the calculator. Here, I'll show you how again, just so that you remember. Okay, so you can go to y equals in your calculator and type in negative 36 divided by x, and then go to your table of values, right? You hit second graph. And it's going to list out all the pairs of numbers that multiply to negative 36. So you're going to have to scroll up and down to see, let me just move this over, to see which pair adds to negative 9. Okay, so I'm looking here. I see negative 3 and positive 12, right? That adds to positive 9. We want a negative 9. So what we have to do is basically reverse the signs. We're going to have a positive 3 and a negative 12. You could scroll down if you want to see it, but here it is. Positive 3 and negative 12, right? Don't they add up to negative 9? So those are the 2 numbers that we're going to put in our parentheses. Okay, so a positive 3 and a negative 12. And let me just move this out of the way so that we could box up our final answer. So here we go. This is fully factored. Okay, I'm just going to do 1 or maybe 2 more with you. So let me take a look at number 29. 29 is a good one. Now, 29, if you notice here, these terms are not written in standard form. And what I mean by standard form is you want to always have your biggest exponent first, then the next biggest exponent, and then the term containing the smallest exponent last. So I'm going to first have and keep the signs with the terms, okay? This is a positive 6x to the 5th, So we're going to have a positive 6x to the fifth. I don't have to put the plus sign there because it's in the beginning, right? It's our first term. Then we have a negative 42x cubed. And then finally, we have a positive 72x. Okay, so we're going to look and say, well, can I factor out a greatest common factor? And yes, we can. First of all, 6 divides evenly into all of these numbers. And look at this, we could also pull an x out of each of these. Okay, we can't pull out more than 1x because this term only has 1x. Now, when deciding whether to pull out a positive 6x or a negative 6x, look at your first term. Isn't this a positive number? So that tells us we're going to pull out a positive 6x. And when we do, that leaves us with x to the fourth. Okay, remember, all I'm doing is I'm dividing each of these terms by the greatest common factor, and I'm rewriting what I'm left with inside one big parenthesis, okay? Do not try to break this up into 2 sets of parentheses when you're factoring out a greatest common factor. When you do a GCF, only one big parenthesis. Okay, so then negative 42x to the third divided by positive 6x will give me negative 7 and then x squared. And then positive 72x divided by 6x is just positive 12. Okay, we don't want to put an x there because although the original term had one, we took it out. Okay, so now I'm going to bring my greatest common factor down. And because we have a trinomial where the leading coefficient is a 1, we're going to open up 2 sets of parentheses. I'm going to put the square root of the first term in the first spot in each parenthesis, right? X squared times x squared gives us x to the fourth. That's why we're putting that here and here. And then we're just going to come up with 2 numbers that add to negative 7 and multiply to 12. So since they multiply to a positive, they have to have the same sign, right? And because they add to a negative, those signs have to be negatives. All right, and this one you probably don't have to use your calculator for. 2 numbers that multiply to 12 and add to negative 7 would be negative 4 and negative 3. Okay, so negative 4 and negative 3. Now, we're actually not done because if you look at this, we can factor further. This is dots, this is a difference, and these are both perfect squares. Before I do so, though, I just want to point out, I know a lot of you guys, when you factor this, right? We take the square root of the first term and put it here and here. And then when you come up with those 2 numbers, some of you might be wondering, why aren't we attaching an x to these? Because this middle term says x squared. Like, where does that x squared come from? Okay, I just want to show you how if I were to multiply this out, it does give me this expression. I'm going to erase this in a minute. I'm just going to show you a quick check. So x squared times x squared is x to the fourth. X squared times negative 4 is negative 4x squared. Negative 3 times x squared is negative 3x squared. And negative 3 times negative 4 is positive 12. So if we combine these 2 terms, right, we get that negative 7x squared that we see in the middle. And then we would bring down the x to the fourth and the positive 12. So, I just wanted to show you why this is equivalent to this right here. Okay, but anyway, let me just keep factoring this. So I'm going to bring down my 6x because that is our GCF. I'm going to bring down my x squared minus 3 because that cannot be factored further. And then this, right, we could factor further using dots. Now, if you remember dots, we set up 2 sets of parentheses. One gets addition, one gets subtraction. We take the square root of this first term and put it in the first spot in each parenthesis. And we take the square root of the second term and put it in the second spot in each parenthesis. Okay, and if you look at all of our factors here, there's nothing else we could do to factor further, so this would be our final answer.